Hi everybody. Review for the quiz on cube root, square root, solving and graphing. Be prepared to really graph just about any kind of square root or cube root function. You can have your calculator for the whole thing. When you're graphing this function, go down the table of values. So we're going to go to second, right, and then graph. That's where you can find the table. And make sure you pick some points off that table. Now you're looking for the very, very first point. After everything says error, 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 find that very first point. And in this case, that is the point -4, -1. So you have to have that point first. Now this point also controls the domain and range. So you can write x is greater than or equal to -4. You could also write -4 to infinity. For the range, you could write y is greater than or equal to -1 or -1 to infinity, because as you can see on the calculator, the graph goes up and to the right. So the x's are getting larger and the y's are getting larger. Then we have the point -3, 0 and the point 0, 1. Please make sure you plot 3 points and make sure that you have one end with an endpoint and one end with an arrow. In a square root function, you want to be careful and look for things that don't work. Not always negative. So check all of your answers, especially when it's in the directions, because that's a nice warning. So we're first going to add the 7. And of course, in order to isolate the square root sign, we'll divide by 3. So now we have the square root of x plus 2 equals 4. Now in order to get rid of this square root sign, we have to square both sides. So this is going to be x plus 2, and of course 4 squared is 16. And then lastly, just subtract that 2, and we get x equals 14. Now, to check this real quick, we have 3 times the square root of 16 minus 7. That would be 3 times 4 minus 7. That is a 5, so it works. This is in my way, so I'm going to just get rid of it. And now let's try this one. Looks a lot like the one we just did. Start by subtracting 7, and we get the square root of x plus 2 is equal to -2. Well, the square root, I can't take the square root of anything and get a negative anything. So this isn't possible. So this can't happen, so this is no solution. If you don't notice that and you go ahead and solve it the whole way, once you check that answer, you'll realize that it doesn't work. In number 6, the radical is isolated already, so we're ready to square both sides. So we get x plus 6 equals x squared. I like to keep the x squared where it is, so I'm going to subtract the x and subtract the 6. This is going to make this 0 equals x squared minus x minus 6. You have to get it set equal, because you're going to have to factor it, because you have the letter squared and the letter. So we have x and x. Now we need 2 numbers. When you multiply, you get 6. 6 times 1, 2 times 3. So there's not many. And of these factors, we need 2 that when you subtract them, you get a 1. So we know we have a 3 and a 2. Now, in order to get a -1, we want it to be a -3 and a +2. Set each factor equal to 0, and you get x equals 3 and x equals -2. We should probably check these. If you put the 3 back in there, you get the square root of 9 equals 3. Oh, that works. If we put the -2 in there, we get the square root of 4 equals -2. Well, just like in number 5, you can't take the square root and get something negative, so the answer there is x equals 3. Describing a transformation. Remember, you're not going to talk about the cube root or the x, but we're going to talk about the 4, the -1, and the +2. So the 4 is a multiple, so you're multiplying by 4, so this is a vertical stretch. And of course, that's by 4. The -1 inside, remember, does kind of what you think it shouldn't. It goes the opposite direction, so this is right 1. And the +2 does exactly what you think. Up is positive, down is negative, so this is going to be up 2. If you're not sure, you can always put it in the calculator and take a look at the graph. Now we're going to solve these with the cube root. So start by adding 5. Notice it doesn't even say check your answers because you don't have to. Make sure you divide both sides by 4 before you go ahead and get rid of that radical sign. The radical sign has to be by itself. And now we're ready to do the third power. That gets rid of everything. The radical sign, the 3's, the third root. We have just x minus 1. 2 to the third is 8. Add 1. We get x equals 9. Now here, this is really a positive 4, so we're going to have to subtract 4 from both sides. So we get x minus 1 to the 1/3 power equals negative 3. 1/3 power is the same thing as the cube root, so we're going to raise both sides to the third power. Oops, that's a negatives inside there. So this is gone. We get x minus 1. Now we have negative 3 times negative 3 times negative 3. Or put it in the calculator. We get negative 27 over there. And when you add 1, negative 26 is the answer there. Because then we get into some stuff with some inverses. Kind of a lot of question about inverses on here. So you're told very specifically the points to graph for this curve. So you can type it in the calculator, but go to the table, and we're very specific. We want you to graph x equals 0, x equals 1, and x equals 2. All right, so when you get those numbers, we get negative 1, 0, and 1. So we have 0, negative 1, 1, 0, and 2, 1. Now, if you're not so sure what the graph looks like, obviously you have the calculator. So between the combination of the numbers that you have plotted and your calculator, you should be able to draw this graph. Now they want us to graph the inverse using the exact, domain and range. Sorry, I forgot about that. Domain, of course, is all reals, and range, all reals. You don't like that? You can use the infinities, negative infinity to infinity, negative infinity to infinity. So if we switch these points, remember inverse means switch the x and y, so then we would have negative 1, 0, 0, 1, and 1, 2. You don't have to do anything to it. You don't have to do any algebra. Just switch the points. So now they're asking us to graph this. So we have negative 1, 0, 0, 1, and 1, 2. So this graph is going to go like this. Probably graphed it a little bit too extreme, but this is the inverse, and this is the function. State the domain and range for this graph. Well, it's kind of hard to tell, but it does go on forever left and right. So the domain is all reals, and the range is also all reals. Now we're going to do some inverses algebraically. First thing is switch the x and the y. So we have x equals y squared plus 4. We're going to subtract that 4. So we have x minus 4 equals y squared. And when you take the square root, as we know, we want to put the plus or minus in front of that square root. And of course, this is your inverse. Use the name with a negative 1 power. Number 15, switch the x and y. So x equals the cube root of y minus 2 with the plus 3 on the outside. Now, when we cube both sides here, don't get so stuck on the algebra. Please do not multiply this out. Leave this x minus 3 to the third. On this side, we just have y minus 2. So when you go to add the 2, we're going to have x minus 3 to the third, and then just a plus 2 sticking out. This is your inverse, and I'm going to use the proper name there. And for p of x, again, switch the x and y. So x equals 2y plus 3 to the 1/3 power. We're going to cube both sides. So x to the third is just plain old 2y plus 3 now. We're going to subtract that 3 and then divide by 2. Now when you do this, you can leave that a giant fraction if you'd like to. X to the third minus 3, that whole thing is over 2. And this is the inverse of p of x. And for the last one, switch the x and y, of course. So now this is x, then the 5 square root y minus 1. You have to divide by 5 first, so please make sure you isolate that radical sign. Now we're going to square both sides. When you square a fraction, you square the top, you square the bottom. And when you go ahead and add that 1, you can just let it stick out like this. Of course, this is the inverse of h of x. Now, as far as these next three go, again, just because we have the graph or have the equations, you can use the calculator to draw the graph if you want to. You can graph the original, which is going to be a little bit easier, or you can graph the inverse that you've calculated and written down. I'm going to graph the original. So if we look at number 14, so this goes to 14, right? That's what it says. They refer to number 14. So 18 really goes to 14. The letters match, so G and G, of course, up there. If we just think about what the graph of G of x looks like, or put it in the calculator and take a look at it. It's like this. So, of course, it fails the horizontal line test. So the inverse is not a function. So we have to state the restriction on the domain. I'm going to cut off the left side. You can cut off either the left side or the right side. So my domain restriction is x is greater than or equal to 0. So I'm just going to use the right side. You could also say x is less than or equal to 0. For number 19, if you graph the original, because it's a little bit easier, it goes like this. And anything with the cube or cube root, we know is all reals. So this one has no restrictions at all. So same thing with 16. We see that 1/3 power, there's not going to be any restrictions. It's only 1/2 power or square root power that we have to worry about. Now for number 17, I'm going to graph the actual answer. I'm going to graph this thing. And so when we graph this, we get, and you can look at it on the calculator, but we get a pretty wide parabola. But this is the point we're looking for. This is the point 0, 1. So then we're going to cut this off. We can cut it off here, or you can cut it off the other side. So again, this is like number 18. You could have x is greater than or equal to 0, or you could have x is less than or equal to 0.